Hello, good morning everyone. Welcome to BYJU'S Exam Prep, India's most largest learning platform. So I hope that yes, the voice is absolutely clear, the video is absolutely fine. So quickly just share the session to all of your friends because here we are going to solve top 11 questions of communication that you have never solved before. This is a fresh question. So those who are listening to me, quickly comment in the comment section and then we will start our session. Okay. So quickly share this session with all of your friends, guys. So these are the top 11 questions so that we can, learn some new concepts through the question. So you can call it as a concept through questions also. Okay, these are the new questions that we are going to solve today. There is a very high chance that you might have not solved these questions before. So I'm just waiting for the other students to join this session. Come on, guys. So I'm seeing students are still joining. Yes, so almost 10 plus students have come. Now, come on, make it more than 20, guys, because it is a new session, the new questions we are going to solve. And just comment in the comment section so that I will come to know that you have joined and I will start the session. And before starting the session, let me introduce myself. So this is Saket Verma, and I am having more than 12-year experience in the field of GATE and ESE, and I have mentored more than lakhs of students, and I teach the subject electromagnetic theory, communication system, signals and system, and for ESE advanced communication system. So this is the very interesting session for GATE 24 students. So if you are in the third year and you are going to appear in the GATE 24, so these are the 5 factors that will guarantee you that to get the under 100 rank, and the session will be taken by the Joseph sir on 24th of January. And we are coming live for the GATE exam analysis. So GATE 2023 exam analysis we are going to do in the 5th and the 11th of February. For 5th February, we are for electrical and EC students, and for 12th of February, it will be for instrumentation and the CS students, right? So this is the first question, guys. Manoj, yes, good morning, good morning. So this is the first question. Come on, solve this question. I am giving you few minutes time. Read the question properly, then we will process with the solution and we will learn the concept through questions. Okay. So we will learn concept through questions. Come on, guys, and share this session to your friends. So this is the first question. ठीक है, चलो देखो इसको क्वेश्चन को पढ़ो, है ना। क्वेश्चन को पढ़ लो, फिर उसके बाद हम इसको वन बाय वन डिस्कशन करेंगे। इसको मैं ऑब्जेक्टिव के फॉर्म में नहीं किया हूँ, ठीक है, ताकि क्योंकि ऑब्जेक्टिव के फॉर्म में करता तो वो थोड़ा एमसीक्यू टाइप का लगता, है ना। ये एक फ्रेश क्वेश्चन है तो मैंने इसको ऑब्जेक्टिव के फॉर्म में कन्वर्ट नहीं किया है। यस सैन ने नियोगी हेमिंग कोड का क्वेश्चन तो मैं नहीं लाया हूँ। हाँ, हेमिंग कोड के क्वेश्चन नहीं है, ठीक है, हेमिंग कोड के क्वेश्चन नहीं है इसमें, फ्रैंकली टेलिंग। So we will learn the questions from all the topics like analog communication, digital communication, random variable, but not for information theory also, but not from the Hamming code. So this is one demand from your side. So I will try to keep one session for the Hamming code before the GATE examination. ठीक है, तो क्वेश्चंस आप पढ़ लिए होंगे। तो ए सिग्नल कैन बी मॉडल्ड एज ए लो पास स्टेशनरी प्रोसेस whose PDF at any time t naught, because it is a stationary process, so we are sampling at time t is equal to t naught। तो जब आप टाइम t इक्वल टू टी नॉट पे सैंपल करोगे तो आपको रैंडम वेरिएबल मिल जाएगा। तो उस रैंडम वेरिएबल का जो प्रोबेबिलिटी डेंसिटी फंक्शन है वो आपको गिवन है यहाँ पे, ठीक है। द बैंडविड्थ ऑफ द प्रोसेस इज, यानी कि जो आपका मैसेज सिग्नल है जो कि लो पास सिग्नल है, इसका जो बैंडविड्थ है ये आपको दिया हुआ है 5 किलोहर्ट्ज, एंड इट इज डिजायर्ड टू ट्रांसमिट यूजिंग ए पीसीएम सिस्टम, ठीक है। तो पीसीएम सिस्टम का यूज करके हम लोग इसको ट्रांसमिट कर रहे हैं। तो अप टू दिस पार्ट अगर मुझे क्या क्या इंफॉर्मेशन मिला, अगर मैं उसको यहाँ पे लिख लूं तो मैं ये बोल सकता हूँ कि मैसेज सिग्नल का जो मैक्सिमम फ्रीक्वेंसी है वो 5 किलोहर्ट्ज है, क्योंकि उसका बैंडविड्थ हमको दिया हुआ है, पीडीएफ हमको दिया हुआ है, और हम लोग यूज कर रहे हैं पीसीएम सिस्टम, ठीक है। कोडिंग डिकोडिंग पार्ट में प्रॉब्लम होता है, यस सैन, मैं इसके लिए आपको एक सेशन रखने का ट्राई करता हूँ कि नेक्स्ट वीक के अंदर, मतलब इस वीक के अंदर हम उस सेशन को भी रख सकें, क्योंकि एक सेशन हमारा यहाँ पे एमएसक्यू बेस्ड होने वाला है। ठीक है, एक सेशन हम लोग यहाँ पे एमएसक्यू बेस्ड रखने वाले हैं 27 को, और उसके बाद में सैटरडे को आई विल ट्राई दैट कि आप लोग के लिए वो वाला सेशन भी ले सकूं। ठीक है, सिग्नल टू क्वांटाइजेशन नॉइज रेशियो, जैसा कि पहला आंसर मेरे पास आ रहा है 1/768। सो जयेश, थिंक ऑफ इट वंस कि सिग्नल टू क्वांटाइजेशन नॉइज रेशियो इतना कम हो सकता है क्या? 1/768, इज इट possible, is it looking possible? Because it is very very less, is it very very less, and we always want to have the signal to quantization noise ratio very large. Okay, and the first part of the question is, if the sampling is done at the Nyquist rate, that is sampling is 2 fm, so it is 10 kilohertz. 32 is also not correct answer. 48 is also not correct answer. Come on guys, keep trying, keep trying. तो नंबर ऑफ लेवल्स आपका 32 है ना। आपको पूछा गया है व्हाट इज द रिजल्टिंग सिग्नल टू क्वांटाइजेशन नॉइज रेशियो। तो चलो मैं इसको यहाँ पे कैलकुलेट करता हूँ, है ना, आप लोग भी साथ में देखते जाओ। तो सिग्नल पावर मैं पहले कैलकुलेट करता हूँ, ठीक है, क्विकली हम लोग कैलकुलेट करेंगे सिग्नल पावर, यानी कि मीन स्क्वायर वैल्यू, और मीन स्क्वायर वैल्यू होगा हमारा माइनस इनफाइनाइट से इनफाइनाइट एक्स स्क्वायर एफ ऑफ एक्स डी एक्स। ठीक है, तो सिग्नल हमारा कहां से कहां तक डिफाइन है? -2 से 2 तक डिफाइन है, एक्स स्क्वायर, और पीडीएफ की वैल्यू -2 से 2 आप लिखना चाहो तो वहां से लिख सकते हैं, या फिर हम इसको क्या कर सकते हैं, 2 टाइम्स 0 to 2 एक्स स्क्वायर, और अब आप इसको लिख सकते हो ये वाला लाइन का इक्वेशन आप लिख सकते हो, जो कि आपका आएगा एफ ऑफ एक्स इज इक्वल टू, स्लोप हमारा -1/4 है, x plus 1 by 2, so minus x by 4 plus 1 by 2, so this is minus x by 4 plus 1 by 2 and dx. Noise power 1/68 आ रहा है 1768, so let's see, है ना, देख लेते हैं सिग्नल पावर कितना है ये बताओ। ये सिग्नल पावर का कॉन्सेप्ट समझ में आ गया, है ना। तो ये 2 टाइम्स हम लोग इसको लिख लेते हैं 0 से 2 तक -x³ by 4, और ये आ जाएगा +x² by 2 इंटू डी एक्स। तो इसको हम अगर सॉल्व करें तो ये आ जाएगा -x⁴ डिवाइडेड बाय 4 मतलब 16 हो गया, और ये x³ by 3 यानी कि 6 हो गया। अब लिमिट आप पुट कर दो 0 से लेके 2 तक, और मुझे ये बताओ कि ये कितना आ रहा है। ठीक है, ये आ गया आपका 16/16 यानी -1 प्लस 8/6, यही आएगा। ठीक है, तो ये कितना आ रहा है आपको, 2/3 दिख रहा है क्या? So signal power is coming as 2/3. Signal power is coming as 2/3, and noise power, because आपने यहाँ पे क्या यूज किया हुआ है, आपने यहाँ पे बोला है कि आप यूनिफॉर्म क्वांटाइजेशन यूज कर रहे हो, तो यूनिफॉर्म क्वांटाइजेशन में आपका जो क्वांटाइजेशन नॉइज पावर होगा वो Δ² by 12 हो जाएगा। तो ये VH माइनस VL डिवाइडेड बाई L, ये आपका स्टेप साइज हो गया इसका होल स्क्वायर डिवाइडेड बाय 12। तो हाईएस्ट वैल्यू हमारे पास 2 है और लोएस्ट वैल्यू -2 है, इसका होल स्क्वायर डिवाइडेड बाय नंबर ऑफ लेवल हमारा 32 था। ठीक है, तो 32 का भी स्क्वायर हो जाएगा एंड डिवाइडेड बाय 1/12। सो व्हाट इज द नॉइज पावर, व्हाट इज द नॉइज पावर, व्हाट अपॉन 1 अपॉन कुछ आएगा ये ओवरऑल, इसको कैलकुलेट कर लेते हैं। चलो आप लोग बताओगे क्या कैलकुलेट करके? तो ये 16, चलो मेरे को ही लगता है कैलकुलेट करना पड़ेगा, तो 16/32 इंटू 32 इंटू 1/12 कर लेते हैं। तो ये आ गया 1/2, तो 64, सो 1/64 इंटू 12, सो 64 इंटू 12 कर लो, फिर देख लेते हैं सही आंसर था कि नहीं। 64 इंटू 12 या 768, यस। तो ये तो क्लियर है कि नॉइज पावर 1/768 आया था, ठीक बोल रहे थे। अब सिग्नल टू क्वांटाइजेशन नॉइज रेशियो निकाल लेंगे। तो सिग्नल पावर हमारा 2/3 है और क्वांटाइजेशन नॉइज पावर अपना 768 है, तो इसको सॉल्व करने पे ये आ रहा है 512। सो 512 आ रहा है, 512। ठीक है, 512 दिख रहा है क्या सभी का? 512 आया आंसर? इसको डीबी में कन्वर्ट कर लो, है ना, इसको डीबी में कन्वर्ट कर लो तो 10 log 512 ये आपका आ जाएगा 27 dB. So the answer is 27 dB. So answer of the first question is 27 dB. Got it? So answer of the first question is 27 dB. Yes. Now let's take second part of this question. We are saying that if the available bandwidth of the channel is 40 kilohertz, if the bandwidth available of the channel is 40 kilohertz, then what is the highest achievable signal to quantization noise ratio? What is the highest achievable signal to quantization noise ratio? So bit rate you are saying 50. Okay, the resulting bit rate also you can calculate the 50 kbps you are saying. So resulting, yeah, 50 kbps is the right answer because resulting bit rate is given by n into fs and the number of levels are 32, so the number of bit required will be 5 and the sampling frequency is 10. So we can say that this RB is equal to 50 kbps. Yes, the second part of this first question. Now let's solve the second question. Second question. Yes, Jayesh, you are right. Absolutely right. So now solve the second part of the question. SQNR is not depending on bits. You are saying, see, it is 40. So channel bandwidth, right? So this here it is given that the channel bandwidth is 40, right? This channel bandwidth is yes, 40. So channel bandwidth is 40, so it is equal to RB by 2. Okay, the minimum transmission bandwidth is RB by 2 in case of PCM. So here this RB is given as NFS upon 2. So what is the value of N? So it is nothing but a 80 into 10 raised to power 3 divided by Fs. Fs is 10 kilohertz, it is fixed. So the number of bit required is 8. Okay, so number of bit required is 8 now. So your signal power is not going to change. So signal power आपका 2 by 3 रहेगा, बट जो क्वांटाइजेशन नॉइस पावर है जो कि आपने निकाला था VH माइनस VL होल स्क्वायर डिवाइडेड बाय एल स्क्वायर एंड डिवाइडेड बाय 12, तो यहां से ये कितना आ जाएगा 2 माइनस 2 हो गया प्लस 2 4, यहां से आ गया आपका 16, सॉरी 4, 4/2 to the power 2n यानी कि 8 और 1/12 यही आएगा इफ आई एम नॉट रॉन्ग. ओके 16 आएगा, ये 16 ही आएगा. That is your 16, that is your 16, 2 minus of minus 2, yes, plus 4 and plus 4 whole square 16. Now because you want to calculate the signal to quantization noise ratio, it is 2 by 3 and this is 16 upon 2 to the power 16 into 12. So ये कितना आना चाहिए आपका 4 और 4 ये 2 यानी कि 32768. Okay, 32768, right? Or in dB, if I calculate in dB, I am calculating it around 45 dB. Yes, good morning, dreamer. So this is the 45 dB. Okay, this is the 45 dB. So that is your second answer. Now, third question. Now the third part of this question. Read this question. Good morning, Ravi. Come on. So you have missed the first part of the question. No problem. So you are having the next 10 questions. So wait for it, and then you can start solving the question from the second one, because this first question we have already solved the two part. Now the third part is, if the instead of sampling at the Nyquist rate we require a guard band of at least 2 kilohertz and the bandwidth of the channel is 40 kilohertz, then what is the highest achievable signal to quantization noise ratio? So you know that, okay, I'm writing here only this third part. You know that the guard band is what it is saying, it is at least, okay, it is at least 2 kilohertz. So guard band should be greater than equal to 2 kilohertz. And what is the formula for guard band? The formula for guard band is Fs minus 2 fm should be greater than 2 kilohertz, right? And we want to calculate the sampling frequency, which is 2 into 10 to the power 3 plus 2 into fm. Fm is 5 kilohertz. So the sampling frequency should be greater than 12 kilohertz. Okay, the sampling frequency should be greater than equal to what? 12 kilohertz. Okay, sampling frequency should be greater than 12 kilohertz. Now the bandwidth is 40. Now the bandwidth is 40, right? So the bandwidth is 40 kilohertz. It is given, and it is equal to RB by 2, which is minimum bandwidth. And again we will take NFS upon 2. So what will be the value of n here? 80 into 10 to the power 3 divided by Fs. The minimum value of Fs is, the minimum value of Fs we have seen that it should be greater than 12. So minimum value is 12 into 10 to the power 3. So this is 6.67. So what should be the value of n to be selected? What should be the value of n? Tell me. What should be the value of n here? What should be the value of n here? So Arnab, Jayesh, both of you are saying 7. Anyone else? So see, if I choose n equal to 7, okay, if I choose n equal to 7, see, very important point here, that is why I am waiting for your answer. If you choose n equal to 7, see what will happen here. If I choose n equal to 7, then what will happen here? If I choose 7, then the sampling frequency will become, from here only you can see, suppose you choose n equal to 7 here, then the formula is, bandwidth is NFS upon 2, right? And bandwidth we required is 40 kilohertz. And if I choose n equal to 7, then what will be the sampling frequency corresponding to this? So corresponding to this, the sampling frequency will be 11 point something. Okay, 11.4 something. Right? 11.4 something it will get, right or wrong? Yes. So in this case, we get the sampling frequency as 11.4, but previously we have already seen that the sampling frequency has to be greater than 12. If we want the guard band of at least 2 kilohertz, it is written that it should be minimum of 2 kilohertz. So if I satisfy this criteria, guard band should be greater than 2, then for satisfying this criteria, the sampling frequency has to be greater than 12. But if I choose n equal to 7, then my guard band is less than 12. So I cannot choose n equal to 7, right? So the value of n we have to choose is 6, because when I choose the n equal to 6, I will get the sampling frequency greater than 12. Got it? Yes, Arnab. Now you got it. Why I am choosing n equal to 6? Is it okay now? So now the question is only, which is to calculate the quantization noise power. So VH minus VL whole square divided by L square into 1 upon 12. So this is 16 upon 2 to the power 2n. Yes, Pinky, hello. And n, the value of n is 6. So it is 6 and into 1 upon 12. Now you calculate signal to quantization noise ratio, which is 2 upon 3 divided by 16 into 2 to the power 12 into 12, and the final answer of SQNR is 2 to the power 11, right? 2 to the power 11 we will get, which is 2048. This is the first question we have solved, and the 10 questions are still left. So you can join the session right now. Okay. So this will be our final answer. 2048 or 33 dB. 2048 or 33 dB is our, yes, good morning Chinmay, is our final answer. 2048 or 33 dB. Okay. So this is our second part, 45 dB, and this is our first part, 512 or 27 dB. Got it? Let's move into the next question now. Yes, good morning Kunal. So this is the next question. This is the next question from frequency modulation. So read the question. This is the second question. A message signal is given to you and it is frequency modulated and the phase modulated. So with the help of this message signal, we are modulating the carrier. First time we are modulating the frequency modulation, and second time we are performing the phase modulation. And we have to find the relation between Kp and Kf such that maximum phase of the modulated signal in both the case are equal. Maximum phase of the modulated signal in both the case are equal. Maximum phase. So what is the maximum phase deviation in case of PM? Can I write directly? That is Kp into maximum value of Mt. If you have any doubt, just please ask. Okay, related to the question only right now. And maximum phase deviation for Fm. Maximum phase deviation for Fm is 2 pi kf integration minus infinity to t m tau d tau. So one answer I have got is option A from Ketki Verma. So these are the two equations we have, and we have to equate these two such that the maximum phase deviation of the modulated signals are equal. So we have to equate this and we will get the value. So from here we will get Kp into maximum value of message signal is 1. So from here you are getting Kp. So from the first equation you are getting Kp. Now how do you calculate the maximum value of Fm? Phase deviation in case of Fm. Okay. So this we have to calculate. So let's write the equation of this line. So y is equal to mx plus c. The slope is 1. That means it is t. Okay. The equation of the line is t here for the 0 to 1. Right. So Case number one, okay, case number one, when our t is, Saurabh is saying option C. Okay, so I have got the two answers, option A and C. Okay, see, when my t is in between 0 to 1, this is again important one. So if my t is in between 0 to 1, okay, is in between 0 to 1, then what will be the phase deviation? So delta phi max is 2 pi kf integration from minus infinity to t. Okay, and what is the value of message signal? It is tau, d tau. So this is, let me write one more line, m tau d tau, let's write m tau d tau. Then this is 2 pi kf integration from 0 to t, because the message signal is defined. The message signal is defined from 0 to 1 or 0 to 3 overall. But right now the t is the case number 1 when I am taking the t is in between 0 to 1. ठीक है, जो t है ये आपका 0 से 1 के बीच में है. So we will write the equation of the message signal according to the limit, which is tau. So when we solve it, we will get pi into kf, and this is tau square by 2, so we will get t square. Okay, when you put upper limit, you will get pi kf t square. Got it? So Arnab Malik is also saying option C. So two answer I have got as option C. Now let's take case number 2, when the t is in between 1 and less than 2. Ashish is also saying option C. So del phi max is 2 pi kf integration from minus infinity to t m tau d tau. So this is 2 pi kf, and it will be 0 to 1. 0 to 1 it is having the equation t or tau in fact. So equation is tau d tau, and from 1 to t. Okay, now I am saying that my t is somewhere here. So I will integrate it from 0 to 1. 0 to 1 the equation is t, that is tau, and 1 to t it is 1. So 1 to t it is constant 1 and d tau. And when I will solve it, this is 2 pi kf limit from tau square, that is 0 to 1, so this is tau square by 2, and here we will get t minus 1. Okay, so finally I will get, I am writing directly, so this is pi into kf, pi into kf plus 2 pi kf and t minus 1. Yeah, so just this is 1 upon 2, and 2 and 2 will get cancelled, and t minus 1 is multiplied with 2 pi kf. Okay, is it clear up to this point? Now case number 3, when the t is greater than 2 but less than 3, and in this case delta phi max is again 2 pi kf integration from minus infinity to t m tau d tau, and this is 2 pi kf, again 0 to 1 we have tau, plus 1 to 2 we have 1, and plus, now the t is somewhere here, which is 2 to t, it is minus 1. So 2 to t, it is minus 1 d tau. So when I will solve it, okay, I am writing directly. So this is 3 pi kf minus 2 pi kf and t minus 2. Okay. Now again coming back to the case number 4. Case number 4, when tau is greater than equal to 3, so delta phi max I am getting as 2 pi kf limit from 0 to 3. Okay, and let me write 0 to 1 it is tau, d tau. Then 1 to 2 it is positive tau. Then 2 to 3 it is minus 1 into tau. So this is minus d tau. Okay. And from 3 onwards it is 0. So we will get only 3 pi kf. Okay, not 3 pi kf, only pi kf because of the first one. The second and third one will be 0. This will be and this will get cancelled because it will give you 1 and it will give you minus 1. And when you will solve it tau square by 2, 2 and 2 will get cancelled and you get pi kf. So you are getting pi kf. So is it clear up to this point? Tell me. First of all, tell me that have you calculated the maximum phase deviation for all the different values of t? Is it clear up to this point? Now I am writing for Fm. For Fm, this delta phi max are, okay, this is pi kf t square. So pi kf t square. Second one we are getting pi kf. So this is pi kf plus 2 pi kf into t minus 1. And then we have the 3 pi kf. So this is 3 pi kf plus minus 2 pi kf and t minus 2, and the last one we have got pi kf. Okay, this is for 0 to 1 t 0 to 1. This is for t 1 but less than equal to 2, less than 2, and this is 2 greater than equal to t 2, which is less than equal to t and less than 3, and this is t greater than equal to 3. Now you tell me what is the maximum phase deviation. Now what is the maximum phase deviation? What is the maximum phase deviation? When you put t equal to 2, you will get the maximum phase deviation, which is 3 pi kf. For t equal to 2, okay, these are the maximum phase deviation. So for t equal to 2, you are getting the maximum phase deviation equal to 3 pi kf. Okay, and for PM you have already calculated. For PM, the maximum frequency deviation is Kp only. That is Kp. So you have to equate these two equations, equation number 1 and 2. So from equation number 1 and 2, this Kp is equal to 3 pi Kf. So that will be your answer. So tell me if you have any doubt in this. So answer is option A. Answer is option A. Okay. You can put the different values of t here and you will see that you are getting the maximum phase deviation only for t equal to 2. So answer is option A. Okay, that is your correct answer, option A. Is it clear to everybody? Okay, so there are different cases. So this type of question, because the limit is important now. When you are calculating the maximum phase deviation, what is your limit of the integration? That is minus infinite to t. So this t is not constant. So this t is varying for the different range. This t is different, and because of this t is different, the maximum phase deviation is different. And because of that, we have the multiple values of phase deviation. And out of all the phase deviation, we have to calculate the maximum phase deviation. Okay, so let's solve the next one. Try this question now. So if you read this question, you will get that this b of n is 0 or 1. Okay, bit 0 and bit 1. And for 0, we will say this is minus 1. And for 1, we are saying it is 1. So probability of minus 1 and probability of plus 1. Both are equally likely. Okay. So they are 1 by 2. These are saying equiprobable. Okay. Equiprobable. So 1 by 2. Now it is saying that we have used the pre-coding technique to form Cn, which is alpha Bn plus beta Bn minus 1 is used. Then the value of alpha and beta such that the power spectral density is 0. The spectral density null at DC, that means f equal to 0. At f equal to 0, we have to get the 0 value of power spectral density. Then what is the irrespective of the pulse shape, it does not depend on the pulse shape pt. Then what should be the value of alpha and beta? Okay, so I hope that you are aware about this type of question, and this is somewhat similar to the binary random process we have studied. Okay, so what you have to do is you have to make the power spectral density 0. Okay, so to make the power spectral density 0, we will calculate the value, that is autocorrelation of C of n. Okay, that is autocorrelation of C of n, that is RCK, which is the expected value of C of n and C of n plus k. Okay, so what is C of n? That C of n is alpha into Bn plus beta into Bn minus 1. Okay, and this is alpha into Bn plus k and beta into Bn plus k minus 1, bracket closed, right? Now in this type of question, you know that you will get something which is in the form of mean square value, and that mean square value we will calculate for certain value of k, and according to that we will calculate the autocorrelation, and we will get the mean square value equal to 1, and mean value not equal to 0 for all the other values of k. So this type of question I hope that you have already done, because this is the last time of examination. It is very near, so I'm sure that you have done this type of question many times, but just that this is a somewhat different in you know there are two different values, alpha and beta. Generally we used to calculate only one constant, so here we have the two different constants. So bn and bn plus k, when you will multiply this with this, plus when you will multiply this alpha and beta, you will get bn and bn plus k minus 1, and again plus alpha beta and bn minus 1 and bn plus k, and the lastly when you multiply this one with this, you are getting beta square and b n minus 1 and b n plus k minus 1. Okay, so now this can be written as alpha square and rb of k, that is the autocorrelation of b, plus alpha b, and that is again autocorrelation of k minus 1, b with k minus 1, and then it is alpha b. When you take the difference, right, the delay you have to calculate. So the delay is, this is suppose t2 and this is suppose t1, so t2 minus t1 you will do, and that is rb k plus 1, and obviously it is discrete, so we will not write t2 minus t1, but yeah, I'm just writing it for your understanding. ठीक है, so ये आ जाएगा आर बी एन माइनस वन विल गेट कैंसल और आर बी के आ जाएगा, और that will be alpha square plus beta square, and then it is rb of k plus alpha beta then it is RBK minus 1 and plus alpha beta RBK plus 1. So this is the autocorrelation we are getting. Now, you know that how do you calculate this RB of K? This RB of K is nothing but the expected value of B of n and B of n plus K. So suppose for K equal to 0, if I calculate, then it is RB of 0, which is expected value of B square n, which is mean square value. Okay, it is mean square value, and mean square value is nothing but there are two values possible, which is minus 1, okay, and plus 1. So this is minus 1 square divided by 1 by into 1 by 2 and plus 1 square into 1 by 2. So you will get 1. And for other value, that is k not equal to 0, this is RBK, which is because it is independent given, right? It is independent, so we can write expected value of B of n and B of n plus k. So here again we are calculating the expected value of B of n. So expected value of B of n is mean value, which is 1 minus 1 into 1 by 2 and plus 1 into 1 by 2. So it is 0. Yeah, yes, correct. Correct, Ketki. So for k equal to 0 and k not equal to 0, we will get, and we can conclude that this RB of k will be equal to uh, or let's write RC. RC of k will be equal to alpha square plus beta square for k equal to 0, and for k equal to plus minus 1 we will get alpha beta for k equal to plus minus 1, and otherwise it is 0. Yes, no need of mean square value minus mean square value. That mean is you are calculating variance statement, but there is no need of variance. Okay, so check once here. If all the values are okay, I am writing the autocorrelation of C, which is RC of K. You will get alpha square plus beta square for K equal to 0. And for K equal to plus minus 1, we will get alpha beta. And for other value of K, you will get 0. For other value of K, you will get 0. Yeah, Kunal, when the k is not equal to 0, when k is not equal to 0, this is expected value of B of n and expected value of B of n plus k I am writing, because actually when the k is not equal to 0, this equation will be followed. Okay, this equation will be followed, and because this B of n and B of n plus k will be independent, here it is mentioned in the question, these bits are independent. Okay, so because these are independent, so ones and zeros are independent, so we can write the expected value of AB as expected value of A into expected value of B. Okay, so I am writing expected value of Bn multiplied with expected value of Bn plus k. So expected value of Bn, if I will calculate, then there are two possible values of Bn, which is nothing but a mean value. Expected value of Bn is nothing but a mean value. So how do you calculate mean value? There are two possible values, minus 1 and its probability 1 by 2, and another value is plus 1 and its probability 1 by 2. So it is equal to 0. Is it clear? Kunal, is it clear now? Yes. So this equation is also clear, that autocorrelation we will get alpha square plus beta square and alpha beta and this one. So now we have to actually calculate the power spectral density. So how do you get the power spectral density of C? The power spectral density is nothing but the Fourier transform. So here you have to calculate the discrete Fourier transform. So n is equal to minus infinity to infinity, autocorrelation, and e to the power. This one is minus j omega n e to the power minus j omega kt. And if, let's write nt, or let's write this one kt. Okay, yes, RCK I am writing. So this is K into T. Okay, so we will get for k equal to 0, that is RC 0, and then we will get for k equal to 1, that is RC 1, so e to the power minus j omega t, and then we will get RC k equal to minus 1, so it is j omega t with the plus sign. So RC 0 we have got alpha square plus beta square, and RC 1 we have got alpha beta, and RC minus 1 also we are getting alpha beta. So e to the power minus j omega t plus e to the power plus j omega t, right? And this one we can write alpha square plus beta square plus divide by 2 and multiply by 2. So this is 2 alpha beta and cos of omega t. So this is your power spectral density of C. So we are saying that at DC at f equal to 0, this SC of f is also 0. So this is 0 is equal to alpha square plus beta square plus 2 alpha beta, cos 0 will become 1. So we are getting alpha plus beta whole square equal to 0. Okay. According to the question, we obtain a spectral null at DC. So DC means at f equal to 0, we have to get the spectral density 0. So what should be the pair of value of alpha and beta so that we get the power spectral density 0. So we have got alpha plus beta square is equal to 0. So for this alpha should be 1 and beta should be minus 1. Okay, so alpha should be 1 and beta should be minus 1. So that is correct answer is option B. Kirti, yes, I am coming to your question. See, generally, don't think of generally. Here you can see that why I am writing for k equal to 1 and k equal to minus 1. You can look from this particular equation. Okay, so I am taking the doubt of Ketki. So Ketki, you can see that you are getting the RC of K as this equation, right? This is the your main equation of the autocorrelation. Now you can see that because you are saying that for K equal to 0 you get the value. So when you put K equal to 1, then this value will also be 0. When you put K equal to 1, then this will become RB 0. Okay, and when this K is equal to minus 1, this will become 0, RB of 0. So you are getting the value 1 for RB of 0, but for which value of K? For K equal to 1 and minus 1. So that is why I have to take other two values of K also, that is 1 and minus 1. ठीक है केतकी, समझ में आया कि मैं K इक्वल टू 1 और माइनस 1 को क्यों ले रहा हूं? क्योंकि आपको K इक्वल टू 0 के लिए तो ये वाला वैल्यू मिलेगा, बट K इक्वल टू 1 के लिए यहां से RB 0 मिलेगा और K इक्वल टू माइनस 1 के लिए यहां से RB 0 मिलेगा. ओके, ठीक है, चलो. So everyone, it is also clear. Now coming to the next question, this is the question number 4. Consider a pulse s of t is equal to sync at and sync bt, where a is greater than b. Suppose that the pulse is to be used over an ideal real baseband channel with one-sided bandwidth 400 Hz. The pulse is Nyquist for 4 pm signaling at 1200 bits per second. Okay, and exactly fills the channel bandwidth. Exactly fills the channel bandwidth. Find the value of a and b. Find the value of a and b. सो सॉल्व करें। यहाँ पे आपको एस ऑफ टी जो सिग्नल दिख रहा है, आपको यहाँ पे ये तो समझ में आ रहा है कि पल्स अगर नाइक्विस्ट है, पल्स अगर नाइक्विस्ट है तो इसमें इंटर सिंबल इंटरफेरेंस नहीं होगा, और इंटर सिंबल इंटरफेरेंस नहीं होने की कंडीशन क्या होता है? फॉर no ISI, no inter-symbol interference, summation n is equal to minus infinite to infinite S of f minus n into Rs is equal to constant. ठीक है, ये आपका सेटिस्फाई करना चाहिए। अगर आप इसको आईएसआई फ्री बनाना चाहते हो तो आपका ये वाला कंडीशन, अगर फ्रीक्वेंसी डोमेन में बात करें तो ये वाला कंडीशन आपका सेटिस्फाई होना चाहिए, एस ऑफ एफ माइनस एन आर एस इक्वल टू कॉन्स्टेंट। ठीक है, अब आपको एस ऑफ एफ चाहिए, तो एस ऑफ एफ क्या होगा? सिंक 80 और सिंक 80 ये दोनों तो टाइम डोमेन में है, तो इसका फ्रीक्वेंसी डोमेन रिप्रेजेंटेशन क्या होगा? सिंक का फ्रीक्वेंसी डोमेन रिप्रेजेंटेशन, सिंक का फ्रीक्वेंसी डोमेन रिप्रेजेंटेशन रेक्टेंगुलर होगा। ठीक है, तो यहां से हमारे पास आ गया ये रेक्टेंगुलर सिग्नल है, ये कुछ इस टाइप का सिग्नल बन जाएगा। ठीक है, यस, रेक्टेंगुलर होगा माइनस ए से ए तक, वेरी गुड। और ये हो गया आपका फर्स्ट वाला सिग्नल, यानी कि सिंक 80 का फोरियर ट्रांसफॉर्म। सो मैं लिख देता हूं यहाँ पे फोरियर ट्रांसफॉर्म ऑफ सिंक 80, ओके, sync 80, or this will be the Fourier transform of sync BT, right? ठीक है, तो यहाँ पे ये हाइट हो गया 1/a, और ये भी माइनस बी से बी तक होगा, ये सब फ्रीक्वेंसी डोमेन में एनालिसिस हो रहा है, और इसका हाइट हो जाएगा 1/b। और ये क्योंकि दोनों टाइम डोमेन में मल्टीप्लाई हैं तो एस ऑफ एफ निकालने के लिए मुझे इसको कन्वॉल्व करना पड़ेगा, और ये जो कन्वॉल्व्ड सिग्नल होगा वो क्या होगा? वैल्यू तो 1/a और 1/b होगा ना, 1 क्यों होगा? वैल्यू तो 1/a और 1/b होगा। ठीक है, और दो अनसिमेट्रिकल रेक्टेंगुलर पल्स को जब आप कन्वॉल्व करते हो, है ना, तो वो यस ट्रेपेजॉइड मिलता है कुणाल, करेक्ट। तो इसका मैक्सिमम वैल्यू और मिनिमम वैल्यू बताओगे क्या? मैक्सिमम और मिनिमम वैल्यू, चलो बताओ क्या आना चाहिए मैक्सिमम और मिनिमम वैल्यू? प्लीज टेल मी व्हाट शुड बी द मिनिमम एंड द मैक्सिमम वैल्यू एंड द हाइट। ओके, हाइट भी बताओ, मिनिमम एंड मैक्सिमम वैल्यू भी बताओ। ओके, यस ड्रीमर, tell the answers of this trapezoid, where it is crossing or where it is changing the slope. So this is a by 2 to minus a by 2, right? Nobody told me this. Yes, Sunny is now right. Correct, Sunny. I was waiting because according to this S of f I will be writing. So the width is a. Width of this rectangular pulse is a. Okay, so width of this rectangular pulse is a and b. So width, and because this rectangular pulse should be symmetrical about the origin, so it should be varying from minus a by 2 to a by 2, not from minus a to a. So this is highest value will be a plus b by 2, and the lowest value is minus of a plus b by 2, and this is a minus b by 2, and this is minus of a minus b by 2, and the height is 1/ab. That is right, that is right. Yes, Jayesh, correct, correct, all of you are correct. Yes, Rupesh, and the height is 1/ab, correct, that is also right. 1/ab, no, I don't think so. 1/ab, wait, I don't think so, it is 1/ab. The slope is 1/ab, right? The slope should be 1/ab. The slope should be 1/ab. The height is 1/a. Height is 1/a. Height is 1/a. How do you calculate the height? The width of the rectangular pulse Okay, sorry, the multiplication of height of the rectangular pulse and the minimum width. Okay, how do we calculate the height? Height is nothing but the 1 upon A and 1 upon B, that is the height of the rectangular pulse, and minimum width. Na? So what will be the minimum width? Here A is more, A is greater than B. So the minimum width will be B. So the height is 1 upon A. Yes, Kunal Ketki, now correct. Jayesh, right. Yes. So the height is the height of the rectangular pulse and the minimum width. The minimum width will be B. So this is 1 upon A. Yes. Now correct. So now you have got the original pulse. Now you have to shift this original pulse with the value Rs. And now what is Rs? Rs is nothing but the symbol duration. Okay. Rs is symbol rate, not duration. TS will be the duration. R is the rate. So symbol rate, how do you calculate the symbol rate? Symbol rate is nothing but the bit rate divided by log base 2m. And what is the bit rate? Bits per second. It is 1200 bit per second and 4 pm signaling we are using. So 1200 bit per second and this is uh, 4. So we are getting 600. So the RS is 600. Okay. RS is 600. So we have to shift the pulse by 600. We have to shift the pulse by 600. And it should be shifted such that the value means after adding all of this, the value should be constant. Okay, so the value will be constant. That means the slope should be cancelled. The slope should be cancelled like this. Okay, so you have to place the pulse in such a way that its slope should be cancelled. That means it is nothing but the summation S of f minus n into Rs, and that is coming to be constant. Then only no intersymbol interference will be there. And because it is given that this pulse S of f, this pulse S of f is a Nyquist pulse. The pulse S of f is a Nyquist pulse, then definitely it will not provide the ISI effect, right? So up to this point it is clear. So this is our original pulse. This is A plus B by 2 and this is minus of A plus B by 2, and now this origin has been shifted to the symbol RS. This is the RS. So this complete duration is your 600. Yeah, Janvi, we are taking the two sessions right now, and then let's hope that if we get the correct time, then we will get that marathon series for the question practice as well. Okay, is it clear up to this point that diagram is clear or not? Is this diagram is clear or not to all of you? Yes. So now what is the meaning of this one? Suppose that the pulse is to be used over an ideal real baseband channel with one-sided bandwidth 400. What is the meaning of this? Suppose that the pulse is to be used over an ideal baseband channel with one-sided bandwidth 400, and this pulse exactly fills the channel bandwidth, and this pulse exactly fills the channel bandwidth. So this is the pulse which we are talking about, and this pulse is having the bandwidth. What is the bandwidth of the pulse S of f? Yes, the pulse is having the bandwidth A plus B by 2, and this bandwidth is completely filling the channel whose frequency is 400. So can I say that A plus B by 2 is equal to 400? Can I say A plus B by 2 is 400? Yes, Kunal, right? So A plus B is equal to 800 because this signal S of F is a Nyquist pulse and it is filling the channel bandwidth, and the channel bandwidth is 400. So what is the bandwidth of our signal, which is exactly filling the channel? The signal which we are having, which is Nyquist, is having the bandwidth A plus B by 2. So this bandwidth will be filled completely through the channel, and the channel is having the 400 bandwidth. So this A plus B by 2 will be equal to 400. Hence we get A plus B is equal to 800. So we have got one equation which is relating A plus B. Now we need another equation which will be relating A and B. Then we have the two equation and two unknown, and we will be able to solve. Okay. Now here you can see that this RS is 600, and up to this point this is A plus B by 2. From this distance to this distance, if I calculate, this is A plus B by 2. So what is the this distance which we are left here? This gap. What about this gap? Yes. What about this gap? That is equal to this gap only, na? That is equal to this gap only. This gap is A minus B by 2. This gap is A minus B by 2. So this gap will also be A minus B by 2. Yes. So RS, which is 600. So RS, which is 600, it is actually sum of A plus B by 2 plus A minus B by 2. So A plus B by 2 is 400. So A minus B, this is also 400, right? A plus B by 2 is your 400. So 600 minus 400 is 200. So A minus B is equal to 400. So this is equation number 2. So when you will calculate this, equation number 1 and 2, when you add, this B and will cancel, and 800 plus 400 is 1200, and this is 600, and the B will be 200. Yes. So this is your answer. Any doubt? After solving equation number 1 and 2, the value of A and B is 600 and 200. This is the answer. Got it? Anyone having any doubt in this question? Let's move into the next question. Okay. Now solve this question. Solve this question. A received upper single sideband with the unit amplitude in which the modulation is signal spectral component has a normalized power of 0.5 volt square. A carrier is added to the signal, and the carrier plus signals are applied to the diode demodulator, that is envelope detector. The carrier amplitude is adjusted so that the demodulator output will be having the 95% of the normalized power in the recovered modulating waveform. Neglect the DC component, then what is the carrier amplitude? Yes, hello Subhareddy. So the received signal is S of t, which is a upper sideband with the unit amplitude. So how do we represent the upper sideband? The upper sideband with the unity amplitude, we will represent it as a cos of omega c plus omega mt, right? Because nothing is given, then we usually take cos. So this is the cos omega c plus omega mt, and we are adding the carrier signal, which is AC. And how do we call any signal as a carrier signal? By its frequency. So that is AC cos omega ct. This signal is given input to the diode demodulator, which is envelope detector. So if I expand it, then I will get cos omega ct and cos omega mt minus sin omega ct and sin omega mt, and then this is AC cos of omega ct. Then you can see that this is we will get AC plus cos omega mt common here, and this is cos omega ct and minus sin of omega ct common, and this is sin omega ct. This is input to the envelope detector or diode demodulator. So what do you think, what should be the output of this diode demodulator? The diode demodulator will detect only the envelope of this signal. And what is the envelope of this signal? The envelope is root over a square plus b square, that is your AC plus cos omega mt whole square plus sine omega, okay, this is sine omega m, so this is sine omega mt, right? Now if I expand it, I will get AC square plus 2 into AC cos omega mt plus cos square omega ct and cos square omega mt and sin square omega mt will become 1. So this will be 1. Okay. So this is the envelope up to this point. Now the envelope is, again I am writing it, 1 plus AC square we have, 1 plus AC square and 2AC cos omega mt. Okay, so let's take this 1 plus AC square common, then we will get 1 plus 2AC upon 1 plus AC square and cos omega mt, right? So we can say that this is a 1 plus AC square and this is nothing but a 1 plus 2AC upon 1 plus AC square and cos omega mt whole to the power 1 upon 2. So because we all know that the carrier amplitude is much larger than the signal amplitude. So if the carrier amplitude is larger, then its square will be more, and this denominator is very high. So if this value is less than 1, then we can approximate it by the binomial expansion, which is 1 plus AC square, and we can write it as 1 plus, this is AC into 1 plus AC square and then cos omega mt. Okay, that 1 by 2 and this 2 will get cancelled. So when I multiply it again, then it is root over 1 plus AC square, and this will become AC upon root over 1 plus AC square and then cos of omega mt, right? And in this question it is given that the neglect the DC component. So here, which is the DC signal? So this is your DC signal, complete constant, and this is your sinusoidal signal. So this DC signal has to be neglected. So we have neglected this part. And what is the power of this? So power of this signal is AC upon root over 1 plus AC square. So this is whole square divided by 2 because it is a sinusoidal signal. Okay. And this is equal to the 95% of 0.5. It is saying that the 0.5 volt square was the previous power, and when we get the demodulator output is 95% of the normalized power. So the normalized power was 0.5 And now at the output of the demodulator, which is this one, this envelope is the output of the demodulator. So this output is having the power which is 95% of zero point 0.5. Okay, so from here you will calculate the value of AC, and I'm directly writing the answer because now it is easy to solve. It is 4.36. Got it? Dreamer, Kunal, Ketki, Subareddy, Ravi, Jayesh, AC is equal to 4.36. It is written here a received upper single sideband. Okay, in the question it is written that upper sideband. Kunal, it is written that a received upper sideband with the unit amplitude. So the signal is upper single sideband, which is upper sideband is denoted by omega c plus omega m. Correct? Any more doubt in this question? Any more doubt in this question? Okay, so it is written that unit amplitude. So unit amplitude, so that is why I have taken amplitude as 1. And because it is asking for the carrier amplitude, so that is why I have taken the carrier amplitude as AC. And how do we identify the carrier? By its frequency. So that is why this is a carrier frequency. This is the upper side band. Okay, this is the upper side band. Got it now? Yes. Let's move into the next question. Okay, now solve this question. Consider a voltage control oscillator using an LC tank and producing an FM signal based on having its capacitance C very, this is VA, very linearly with a message MT as follows. The carrier frequency of the FM signal available at the output of the VCO is 95, and if the VCO produced the FM signal turn out to have a bandwidth equal to 180, that is computed by the Carson rule, and message signal is assumed to have the frequency 15 kilohertz, then and amplitude is equal to 2 volt, then we have to find the value of this constant k. Value of this constant k we have to calculate. Okay. Okay, Amar. Random process through LTIS. This one session can be taken in this particular topic also. Actually, when there is a common part which is everyone is demanding, then it is better to come live, because otherwise only two or three students will watch, then it looks very odd. When you are teaching and nobody is watching, then it looks very odd. So that is why there should be some common topic which everybody wants, then we have to then I will think of taking the live session on that particular topic or the question series, because we take, and if the students doesn't come now, so it doesn't look good actually. It is not like that we are demotivating, but we are not going to demotivate by this, because now we have already experience of taking the sessions. Yeah. Option A, no, not really. Okay, this is I think this is -3. Let's check. Okay, options in the option A and B, these are the -3. 1.57 into 10 to the power -3, because in the option C also you can see that it is -3. So it is by mistake, it is written, I think, -13. It is -3 in the option A and B also. So let's take a solution of this question. So we know that the frequency of voltage control oscillator, okay, the frequency of oscillation is given by, if I write, okay, this is C is equal to C naught 1 minus kmt is given, right? So I can write the instantaneous frequency, because it is not a constant now, the capacitance is varying, so we write it as a instantaneous frequency. So 1 upon 2 pi, and if I write omega I, let's write omega I, then omega I, this is L into C. What is C? This is C naught 1 minus k into mt. Okay, so here we will calculate this. We know that how to solve this parameter variation method. In the derivation of the parameter variation method, this is L C naught, you will take common, and this is 1 minus k upon C naught into mt. Yeah, okay, Amar. Yes, I think I can recognize, not exactly, but yes, because by the name I thought that I know you. This is LC naught. It is 1 minus K upon C naught into MT whole to the power 1 by 2. And when it will go into the numerator, okay, when it will go into the numerator, it will become omega C. And this will be 1 minus K upon C naught into MT and whole to the power minus 1 by 2. So this omega C, let's multiply first. Okay, now omega C is 1 minus, minus 1 has become plus. So this is kmt upon 2c naught. Okay, so this you will get. Yeah, actually these are the tough questions that I am telling. C naught 1 minus kmt na. So C naught is common, 1 minus kmt. If I take C naught common, then it is correct. Jayesh. So this omega I will become omega C plus K, and this omega C naught is there na. Wait, wait a second. Yeah, yes. One more thing. Yes, C naught will not come. C naught will not come because C naught is already common. So C naught is already common. Yes, C naught is already common. So this C naught will not come. Yes, yes. Kf is not coming equal to Kfc upon 2 C naught. Let's derive. Let's derive. We will check that. Okay. So put it equation number 1. Put it equation number 1. Now, okay. So after this, we know that the instantaneous frequency in case of FM is given by omega c plus 2 pi kf and mt, right? Put it equation number 2. Is it clear or not? This omega for FM. For standard FM, we know that the instantaneous frequency will come as omega c plus 2 pi kf mt, because we know that this theta is equal to omega c t and 2 pi kf integration mt dt. So if I differentiate it with respect to time, I will get omega I. So omega I is nothing but a d theta by dt. So this is omega c plus 2 pi kf into mt, right? So we have written directly here. Now if you compare, what you are getting is, this is k into mt upon 2 into omega c is equal to 2 pi into kf into mt. Okay, 2 pi kf into mt. So actually this mt and mt will get cancelled, and we will get 2 kf. Why I am writing 2 kf, I will tell you. This k into omega c upon 2 pi. Okay, is it clear up to this point? K into omega c divided by 2 pi is equal to 2kf, right? Now, now if I want to write the bandwidth, because now we have another information about the bandwidth which is calculated by the Carson rule. So this is 2 times maximum frequency deviation plus message signal frequency, and the maximum frequency deviation is nothing but a kf into am, and the message signal frequency is fm. So the bandwidth given is 180, and the message signal amplitude is 2, and message signal frequency is 15. So this is 180. Okay, this is 180 kilohertz, and this is 2 times value of kf we don't know, but the message signal amplitude is 2 and the message signal frequency is 15. So from here you will calculate 90 minus 15. How much is 90 minus 15? It is 75 kilohertz. So 2 kf is equal to 75 kilohertz now. So 2 kf is equal to 75 kilohertz, right? Now substitute the value of 2 kf here and you will get the value of k. The value of k is 2 kf multiplied with 2 pi divided by omega c. So 2 kf is 75 into 10 raised to power c. Okay. And what is the carrier frequency? This is 2 pi fc. So 2 pi will get cancelled and you will get fc only. What is fc? 95 megahertz. So that is 75 into 10 raised to power 3 divided by 95 into 10 raised to power 6. Okay. So it is coming as 0.789 into 10 to the power minus 3 volt inverse. Is it clear? Jayesh, is it clear now? Actually, what is happening, when you are comparing with the standard equation, why you are not getting kfc upon 2 c naught? Because here the c naught is common in the equation. Actually, generally we write this equation as c naught minus k into mt. That is the oscillator voltage control oscillator capacitance, c naught minus kmt. But in this equation, this c naught is given as common. So that is why you cannot apply the direct relation which we have derived in the parameter variation. Okay. So you cannot apply the direct equation over here. You have to check whether it is given a standard equation or not. And if it is not given as a standard equation, then you have to derive it. So that is why I have derived it here. Okay, this one is the standard. And if this is a standard, then you can apply this Kf is equal to K into Fc upon 2 C naught. Okay, but this is not a standard. So we have to derive. Clear, Jay? That is why we have to derive. Okay, let's move into the next question. So I hope that it is clear to everybody. Let's move into the next question. Yes. Now consider a stationary random process having an autocorrelation function given by Rx tau is equal to a square by 2 e to the power minus 2 mod tau cos omega naught tau. Then assuming the bandwidth of the random process as 5 kilohertz and it is uniformly sampled at the Nyquist rate, the bandwidth required for the transmission if the non-return zero signaling is used with the minimum signal to quantization noise ratio is 40 dB. So the signal power is autocorrelation at 0, that is your a square by 2. Okay, autocorrelation at 0 because the signal has the autocorrelation and we know that from the property of the autocorrelation at tau equal to 0 we get the mean square value which is the total average power. So average power is a square by 2, so that is 12.5. So we get the signal power. What about the signal to quantization noise ratio? It is 10 raised to power 4, which is signal power divided by noise power, quantization noise power. Okay, this 40 dB I have converted directly. 40 dB that I have converted directly. So from here, this quantization noise power is signal power, which is 12.5 divided by 10 to the power 4. So if you will calculate it, you will get 1 upon 800. Okay, and this quantization noise power is delta square upon 12. Okay, so the delta is nothing but a VH minus VL whole square divided by L square into 12. It is equal to 1 upon 800. Okay, now calculate the value of L. What is the value of L? So I think you can see that, right? Okay. So now if you will calculate the value of L from here, this is 81.64 we are getting. Okay, so the calculation you can do here, VHVL value you can substitute and then this value of L you will get, and what will be the value of N? N is equal to 7. For 6 we will get 64, so for N equal to 7 we will get. So now, what is the bandwidth for non-return zero? For non-return zero, the bandwidth is RB. The bandwidth is RB. So RB is equal to N into Fs, and we have calculated as 7. The maximum bandwidth is 5, and we are sampling at Nyquist rate. So this is 2 into 5. So that is equal to 70 kilohertz. So answer is option B, 70 kilohertz. For non-return zero, the bandwidth is RB. Remember, for non-return zero, for for non-return zero. Okay. Yes. So that is easy one, 70 kilohertz, and that is also not lengthy. Now this is also a bit easy. I am asking only one part of the question so that we can, if you know the concept, then you can solve, and then for other part also you can calculate, means just opposite. Now read the question and solve it. Now we are left with the three questions now after this. Seven question we have done. The receiver in a binary communication employs a decision statistic Z which behaves as follows. Z is equal to N if 0 is sent, and Z is equal to 4 plus N if 1 is sent. N is modeled as the Laplacian density Pnx equal to 1 by 2 e to the power minus mod x. For the decision rule delta Z, for Z less than 1 we take decision in favor of 0, and for Z greater than 1 we take decision in favor of 1. Then what is the conditional probability given that 1 is sent? What is the conditional error probability given that 1 is sent? So error probability, we want to calculate the conditional error probability of 0 when 1 is sent. That means our aim is to calculate probability of receiving 0 when 1 is sent. Okay. So when we will take decision in favor of 0, then error will occur. If 1 is transmitted, okay, if 1 is transmitted or sent, error will occur. Okay, if 1 is transmitted, error will occur only if we take decision in favor of 0. So when you will take decision in favor of 0, according to the decision rule, you will take decision in favor of 0 when Z is less than 1. So according to the decision rule, we will take decision in favor of 0 when Z is less than 1. Okay, and because the signal 1 is transmitted, the Z should be 4 plus N. That means 4 plus N should be less than 1, or you can say that N is less than minus 3. So when the noise voltage is, no, answer is wrong. When the noise voltage is less than minus 3, then we take decision in favor of 0. Okay, because we are taking this condition that Z is less than 1. Yes, Dreamer is right. So now probability of receiving 0 when 1 is transmitted is, the noise voltage should be minus infinity to minus 3. The noise voltage should be less than minus 3, so that is minus infinity to minus 3. You have to integrate the PDF, and the PDF is, the noise PDF is given as Pnx dx. Okay, so when we solve this one, this is nothing but a minus infinity to minus 3. It is 1 upon 2 e to the power plus x dx. I hope that it is, you are able to see this, e to the power minus 3 divided by 2. So the answer is 0.025. Okay, for time being, let me hide myself. Yeah, now you can see that e to the power minus 3 by 2 you are going to get. Is it clear, Jayesh? I hope that you have found your mistake. If 1 is transmitted, error will occur. Error will occur actually. Error will occur only if we take decision in favor of zero. Okay. Now solve this question. So this is your power spectral density SXF. Height is 10. Height is 10 and it will be minus 50 to 50. Height is 10 here. Sx of f, and this is f. The equation of the line is Sx of f is equal to, slope is minus 1 by 5. So this is f by 5 and the intersection is at 10. So minus f by 5 plus 10. Minus f by 5 plus 10 will be your minus f by 5 plus 10 will be your equation of the line. Now you are going to pass it through the rectangular signal. First of all, let's draw the rectangular signal which is having the width at 10. So the width is 10, that means minus 5 to 5, and the height is also 5. So this is the rectangular f upon what? 10. Now you are going to shift it by 20 in the left hand side and in the right hand side. Okay. So when I shift it, so I will draw the diagram again. This is my triangular signal, and when I am shifting it to the 20 and minus 20, what I will get is, answer you are getting is D. Okay. Let me check. So this is our Sx of f. This is our filter, let us say h of f, which is having the amplitude 5 and it will shift to 20. So it will shift to 20, that means it will be from 15 to 25. Okay. It is also minus 20, minus 15, minus 25. Now this is our output power spectral density, whatever it will be. Yeah. So answer you are saying D. So I will tell that your answer is wrong. Okay. So what will be the output power spectral density? So first of all, this is your 50 and this is minus 50 and this is 10. So this s of x for positive side I have calculated. Okay, for positive side I had calculated, which is minus f upon 5 plus 10. Okay, so you are going to pass only from 15 to 25. So at 15 and 25, what will be the amplitude? At 15 it is 7 and at 25 it is 5. So 7 and 5, right? So the height will be 7 and this height will be 5. But but we know that the output power spectral density is equal to h of f mod square multiplied with the input power spectral density. So the input power spectral density has the amplitude 7 and 5. Okay, it has the amplitude 7 and 5. So h of f mod square. So when you will take mod and square it, that means 25. So 25 into 7. So this will be 25 into 7 and this will be 25 into 5. So this is 15 to 25. It is minus 25 to minus 15. So now you will calculate the area. Yes, answer is B. Now we know that the power, because we want to calculate the power, so that is nothing but the total area under the power spectral density. So total area under power spectral density. So that is twice of area of this rectangular part, that is your 10 into height, which is 125, plus 1 by 2 into base is again 10 and the height is 2. So when you will calculate you should get 3000. 10 into 5, this is 10 and this has 5. So 10 into 5 is 125. So we should get this answer. What is that mistake I have done? 10 into 2, 1 by 2, 10 into 2, that's 2 and 2 and cancel. We'll get 10 and here we are getting 125. 120, is there any minus then or something? 10. Okay, okay Sunny, e to the power minus 3 upon 2, 0.024, that is right. Are we getting 3000 after solving this? Check once, 1250 plus 10. But 1260 into 2 we will not get 3000. Huh? What we have missed? What we have missed once, can you tell me? Okay, that height is not 2, that is 25. Na? That is 25. 125 plus 1250. This is 50. So 250. Yes, now it is correct. Okay, now it is correct. Yes, answer is B. Actually, the this height is 50. This height is 50 and this height is 10. So 1 by 2 base is 10 and the height is 50, not 25. Okay, because obviously 25 is common. So 7 minus 5 is 2. So 25 into 2. So that is 3000. Got it? So answer is option B. Okay, let's solve another question. Now solve this question. It is very easy. This one is very, very easy. Out of all the previous 10 questions, including this one is the easiest one. Consider the following constellation diagram. Are you able to see the constellation diagram? Yes, because whatever you are seeing in the positive side, that is same in the negative side also. Okay. So, but for your simplicity, I am just hiding myself for a few seconds. Okay, the question you can see, it is completely symmetrical. Now you have to tell the probability of error. So the probability of error is given by, if constellation diagram is given, only constellation diagram is given, then we can calculate the probability of error by d minimum square upon 2 into n naught. Okay. And what is the value of d minimum square? So here the d minimum means the Euclidean distance, which is the minimum distance between the two consecutive symbols. So this will be giving you the d minimum. This will give you the d minimum, which is d minimum square is equal to a square plus a square, which is equal to 2a square. Okay, so the d minimum square is 2a square upon 2 into n naught, and 2 and 2 will get cancelled, and a square is a, the value of a is 2, so that is 4, and the value of n naught is 8. So that is nothing but q of root over 0.5, that is option B. Q of root over 0.5. Got it? Okay, because other symbols, these symbols will have the more distance, this symbol will have more distance. So we will only calculate minimum distance, means we will calculate all the distance, but obviously we will take only minimum distance, and we know that this is the smallest distance. Okay, now solve this one. This is the last question, guys. Come on, solve it in the 2 minutes. Yes, Sunny, I think why your answer is coming so late, Sunny? B is correct, 3000 watt is correct. We have already solved one more question. Maybe you are, solving the previous questions. You joined late, might be. So after quantization, we get that minus 4, 0 and 4, only three values, and we want to calculate the entropy of the quantized source. So what is the probability of minus 4? The probability of minus 4 is sum of probability of minus 5 and probability of minus 3. So what is the probability of minus 5 and minus 3? So when we add these two probability, we will get 0.15. So the probability of 0 is equal to probability of minus 1 plus probability of 0 plus probability of 1. Okay, that is the probability of output. Na? That is the probability of output. So we have to add these three probability. So when you will add these three probability, you will get 0.30. And when we want to calculate probability of 4, it is the sum of probability of 3 and probability of 5. So probability of 3 and 5, that means this one. So when you will add them, you will get 0.55. So now you have the three values and its probability. So what is your quantization entropy of the quantized source? So entropy of the quantized source. So entropy of quantized source. Okay, entropy of the quantized source, the probability you have got, so this is the minus sign, 0.15 log base 2 0.15 plus 0.30 log base 2 0.30 plus 0.55 log base 2 0.55. So calculate the answer and tell me what is the answer you are getting. Yes, 1.4 we are getting. 1.4 bits per symbol. So answer is option B. Okay. So this is it for the today's session, and I hope that this 11 questions will be was helpful for you. So just comment once and let me know that whether these 11 questions were helpful for you or not. How many of you have solved questions from these 11 questions previously? Because according to me, it should be new one for you. But if you have solved any question previously out of 11, do you think that you have seen a few questions before? You can comment like two, three questions you have seen before, or all 11 were new for you. Thank you, Janvi. Thank you so much. Thank you, Dreamer, Chinmay, Jayesh, Sunny. Okay, so all questions were good. So you enjoyed the session. I will try to keep one more session. Okay, one question is there, one session is there in the Friday. So Friday we will be having the MSQ question on the communication. Okay, and that will be around again 7 to 8 questions for MSQ. That will be will finish within 1 hour because I will not keep that tough. Two questions we solved in the class. Okay, Rupesh, yes, this question you might have solved in the class, and then sync A and sync B. That question you solved in the class. So you are my paid student. So yes, you might have solved. For YouTube students, it might be new one. Question number 7. What was the question number 7? Yeah, this question you can solve. You can check it once. This is VH minus VL, might be you are having the doubt. So it is now your duty. How do you find the VH minus VL? Yes, Vishal. So think of it once. I have told you answer. Now you just do the heat and trial and think that what should be VH and VL. The L should be 81.64. Then keep the value of VH and VL in such a way that you will get the L is equal to 81.64. Well, other students can help you if you ask the other students. Can anybody tell what is the VH and VL in this question? Help Vishal. Yes. Vishal, that the value of A is 5, not the peak value. Okay, so it is homework for you. It is homework for you, Vishal. So this is the GATE and ESE test series are going in our app. The link is given in the description. You can go and you can give your full length mock test, subject test, and by the link. And everything which you are looking for, everything is there in the link. So go to the link given in the description and find your according to your interest. Okay. So thank you for watching this session. We will meet in the next session, that is on Friday. I am coming with MSQ and we will be solving 7 to 8 questions of MSQ. That will be also good one. And we will not keep that session too much long. That will be finished in 1 hour. So keep your 1 hour for Friday at 9 p.m. Okay. Thank you.